Lesson 4, Interpreting and Computing Division of a Fraction by a Fraction. More models. Goal. Use visual models such as fraction bars and area models to divide fractions by fractions with different denominators. Make connections between models and multiplication of fractions. Before we begin this lesson, we're going to do a couple things to refresh our memory on fractions. First, we want to turn the following mixed number into an improper fraction. Now, there's a couple ways to do this. I'm going to show you the way that makes sense out of the problem, and then I'll show you the shortcut. So if we have 5 1/4, the fraction is fourths. So what I want to try to figure out is how many fourths is in 5 wholes. So if I think about if I have 1 whole, I would have 4 fourths. So if I had 2 wholes, I would have 8 fourths, because I'd have 4 fourths plus another 4 fourths. If I had 3 wholes, then I would have 12 fourths. If I had 4 wholes, I would have 16 fourths. And if I had 5 wholes, I would have 20 fourths. So if I have 20 fourths, if this 5 is the same as 20 fourths, and I have another 1/4, then together I would have 21 fourths. Now, some of you might have been taught a shortcut where you just multiply your denominator times the whole number. The 4 times 5 is 20, plus 1 making 21, and then you keep the same denominator. And that's because 5 wholes is 20 fourths, and we have this extra 1/4, so that's why we're multiplying and adding to get 21 fourths. Some people accidentally do it the wrong way, so if you understand why and what you're doing, then hopefully you will do the right shortcut, and you'll think about really what does this 5 mean in terms of how many fourths. So again, 5 1/4 is equivalent to 21 fourths. This is called an improper fraction. This is a mixed number. Write at least 3 equivalent fractions for the following fraction. Here we have 2/3. So you could pause and write a few equivalent fractions, and maybe they're going to be the ones that I'll put up. If you want, you can just follow along as well. So 2/3, I can multiply by the same number and get an equivalent fraction. If I multiply both the numerator and denominator by 2, I would get 4/6, and that would be an equivalent fraction. I could multiply these original numbers by 3 and get 6/9. That's an equivalent fraction. I could also multiply them by 10. And that is 20/30. That is equivalent to the 2/3. Example 1, Molly purchased 1 3/8 cups of strawberries. This can also be represented as blank. So 1 3/8, if I wanted to change this to an improper fraction, 1 whole would be 8/8, and we have 3/8 here. So together we would have 11/8. She eats 2/8 cups in a serving. So how many servings did Molly purchase? So we're going to go ahead and do a visual for the strawberries. I'm going to shade in 11/8. Because that's an improper fraction, I'm going to have 2 rows. My first row is going to be 8/8. If that is 8/8, then I need 3 more 8s. I'm just writing 8/8 and 3/8 just so we know the shaded is 11/8. So it says she eats 2/8 cups in a serving. So every 2 out of 8 is 1 serving. So there's 1 serving, another serving. And now I only have 1 more shaded, but because I need to circle groups of 2, I do need to include it with one that's not shaded. So if I look at this, I'm going to figure out how many circles do I have, how many servings with both the 2 out of the 8. There would be 1, 2, 3, 4, 5. And then what's left over? This is a partial serving, so it's 1 out of 2. And I write it just like that, 1 out of 2. So 5 and 1/2. That is how many servings Molly purchased. This example had common denominators, but now we're going to be looking at unlike denominators. So we're going to try an example And we're going to see how it's similar to this problem, but now it's going to be with unlike denominators. So now imagine Molly's friend Xavier purchased 11/8 cups of strawberries, and that he eats 3/4 cups in a serving. How many servings has he purchased? Use a model to prove your answer. So again, I want to shade the same amount, 11/8. Here's 8/8. 3 more makes 11/8. And now the 11/8 divided by 3/4, I need to find a common denominator that will go with 8 because 4 can go into 8. So I want to make this equivalent to so many 8s. So to go from 3/4 to so many 8s, I would double this. So I would double my numerator because 4 times 2 is 8, so 3 times 2 is 6. I want to do the same thing to both the numerator and the denominator. And now I'm going to circle groups of 6. So I have one solid group all the way filled, that's one whole. And now I have 5 out of the 6. So that means I have 1 and 5/6 servings. My last one is 3/4 divided by 2/3. You can think of it as how many 2/3 are in 3/4. What I want to do is make a common denominator between the 4 and the 3. Because 3 can't go into 4, 4 can't go into 3, I can think about a number they can both go into. They can both go into 12. So 3/4 would be the same as how many 12? So if I multiply the 4 by 3 to get 12, I multiply the 3 by 3 to get 9. If I want to go from 3 to 12, that's multiplying by 4, so I need to multiply the 2 by 4 to get 8. So I would want to shade 9 out of 12. If I'm shading 9, there would be 3 left over out of the 12. Now you're probably wondering why there's an extra set here down below, so you'll see in just a minute. If I need to circle groups of 8, here's a group of 8, but I have one more that's shaded, and I only have 1, 2, 3, 4 left. So that's why I need this extra row at the bottom, just so I could circle another group of 8. 4 and 4 make the 8. So this answer would be 1 whole and 1 out of 8. So the answer is 1 and 1/8. Please remember to do your reflection by writing a comment or a question on the left-hand side of your notes. Also rate yourself if you're green, yellow, or red, so you'll be writing when you come into class tomorrow. If you're able to, provide your own example and a model of the answer.